Hello and welcome to From A to Z Azure Virtual Conference on Security and Threat Prevention. I am your presenter, Kit Skinner. I'm a cloud trainer architect here at Opsagility. Skill Me Up here providing this service today. Just to give you all a little background about myself, I am a trainer here, as I said at Opsagility. Skill Me Up. I have an MCT, been doing training for a few years now. Before that, I was doing consulting, doing a lot of things in the field, especially around IT, infrastructure, and security relating to the cloud and on-premise environments. I have several years' experience of being directly in IT, doing design, architecture, security, several different aspects around the infrastructure environments. If at any time you have any questions, feel free to reach out to me. I'm available via either email, LinkedIn, social media aspects. Feel free to reach out to me. I'm happy to answer any questions or have any comments. I'd be happy to address those. All right, without further ado, let's go ahead and talk about what we're going to be doing today. We're going to be focusing around the security tools from Azure. Also, then we'll be talking a lot about some of the threat protection options that we have in Azure, and then how we can deal with the alerts and responding to potential threats that are found in the Azure environment. As I mentioned, let's go start off with the security tools that are available in Azure. Now, Azure's tools are based around the defense in depth concept. But for those that aren't familiar with the defense in depth, the idea here is that rather than just focusing on a particular area of doing security and then assuming everything else is secure, we want to try and make sure that at each level, at each area, we have tools that help us provide security and protection so that if any one area is potentially breached, we have additional tools that can allow us to continue to protect and secure the environments. The physical security obviously is going to be handled by Azure itself, since we are in a cloud environment. They're going to be the ones responsible for it. However, if you do a hybrid type of environment or something with the data center, obviously that physical security would be maintained by those places, but it wouldn't initially be managed through Azure itself. So that's why there's not tools listed around physical security, but they obviously Microsoft is taking care of those physical security properties, things like securing the facilities, limited access to the actual physical environment, and encrypting all hardware and data on the actual physical devices. Those sorts of things are done as physical security protections. Then, of course, it's getting into the identity and access. That's who's identifying who has access to the environment, so you can authenticate people reliably, regardless what it is. And we'll talk about a lot of those tools around it. Then you get into the perimeter. That's getting into the edge of the environment, how we can secure the information as it's being accessed, towards the edges. Then you start getting into the networking itself, the intercommunications between the different environments, the different networking pieces. Then you have also the compute beyond that. Once you've gone from the network, then you're talking to an operating system or some sort of compute protection system. And there's going to be security around those, whether it be something that's a general virtual machine host or something that is maybe a container-based solution. Then obviously the application itself. The application, because it would be something that would be developed by you, that may not be directly related to Azure. However, there are definitely tools around development around it, but there's not necessarily something tied directly into Azure for it. Those tools can utilize things like log insights, monitoring agents, and then also identity protection and those sorts of things as well to protect the environments. And then finally, getting down into your actual data, the actual protection around it. A lot of those are based around the Defender tools, the Microsoft Defender platform, and the Azure information protection tools that are available. Again, that's just kind of a high level talk through, how we're looking at the different tools, where they end up in the different areas, and we're going to be diving into even some more tools beyond that. But that gives you an idea of what we're looking at from a conceptual standpoint in the Azure platform. In addition, on top of that defense in depth is the zero trust model. Because the environment is expected that each level is going to be protected, what we also do is assume that there's not an implicit trust. Traditionally, in older environments, a lot of times if you're inside a private network, they would assume that would be a trusted machine, regardless of what was going on in the environment. If it was something on your internal server network, a lot of times they had just open network communications between them. This obviously caused problems because there would be maybe one potential system that was compromised, and then that was allowed to be a jump and access additional information in additional environments. By adopting a zero trust model, what you're assuming is that you're going to authenticate and validate any communication, that you're going to only have the communication that's expected between the different environments without going through and just blanketing, accepting that somebody has access or a particular system has access just because it's in your environment. Instead, we're going to try and limit that access. And this is the idea behind the zero trust model, is that you're going to verify that each step along the way has access to only what it's needing. So one of the main key pieces once we start getting into the environment is actually doing the identity platform itself. This obviously encompasses Azure AD, but it's also the identity platform that allows you to develop your code and utilize identity pieces, whether it be a third-party tool for something like Facebook authentication, Google authentication, LinkedIn, Microsoft accounts, or Azure AD. By having a single development platform, it allows you to offload the identity pieces to a very secure and robust system, and you're not having to try and maintain that information within your application. This also allows it to be a very simple production design, in the sense that you can use the same library, whether you're using Azure AD authentication or using business to consumer BTC type of authentications, where you're doing federated authentication to something like Facebook or LinkedIn. Those types of tools are then the same code, the same libraries that you would do to access your corporate environment, and access Azure AD authentication allows you to do authentication against other environments that were maybe brought in as a B2B or a guest access from another Azure AD tenant or Microsoft Authenticated. This also allows you to register your applications with the identity platform, so that then you can authorize people and groups of users to access your application directly. This allows you to have the people log into Azure AD, do a single sign-on. You can then authenticate them at that point, and then you can authorize a group of users to have access to that application. And then once they're in the application, you can pass along the information about the user to then grant them access within your application itself. But again, you can have that gateway, the identity platform, to say if they're not even in this group, we don't even allow them to be authorized to access the application, to even have additional access inside of it. That's handled again at the identity platform as to whether or not they're able to access the application because it's been registered there. You can also use the Microsoft Graph information to gain additional information about the users, and you can authorize an application to have only the access that you want to have in it. And then users can also be prompted to say, yes, I want to grant them access to gain information like my name or my email address, those sorts of things. Again, that's something that's available to you in those libraries. So you're trying to make it to where you're not having to go off and code all that information. You're not having to maintain a user database inside of your application that can potentially be compromised. All that can be handled by the identity platform in Azure. And then obviously, if you're going to be having an Active Directory presence in Azure, there are several tools that are built into the Azure AD platform to let you secure and maintain the information of your users and your applications as well. The idea here is that we have a tool, a central repository for all of our users and all of our information about those users, and their identities and their resources, so that we can make sure that we consistently use that information regardless of what resource they're accessing. Doesn't matter whether you're accessing the Azure portal for management, or accessing Microsoft 365, or accessing a custom-made application, or even a third-party tool. All of those can do the same authentication mechanisms through Azure AD. So we can make sure that we have multi-factor authentication enabled for users that need it. And then any other application that they're accessing can also utilize that same multi-factor authentication. We can also do identity access prevention, identity access management, regardless of what application they get through. So just by enabling it through Azure AD, even though we may have been wanting it primarily for a Azure access or maybe for Microsoft 365, if you have a small internal company tool that you've developed, that can use those same tools as well by having it all in the central platform. We can also integrate authentication with our on-premise environment by utilizing Azure AD Connect, to where it can synchronize the information from an on-premise Active Directory into Azure Active Directory so that we can maintain a single username and password for those users, and we can also monitor the access for those environments by them accessing those same tools. By limiting the logins and the different authentication mechanisms for the users, what we're striving to do is make it easier for the users to log in on a standard basis and be able to authenticate them explicitly and say that they are who they say they are, without them having to maintain multiple different passwords, multiple different logins that could potentially be compromised in different ways. Having one password across all the different tools and then stored in all those different environments makes it very difficult for them to make sure that it's easily monitored and making sure that it's not reusing it in multiple places. But by storing in Azure Active Directory, what that allows us to do is that we can even get to a passwordless state, where we can even have them do just biometric and multi-factor types of authentication and ensure that they are that human being, that they are using some sort of additional tool to authenticate it, not just have a simple password that's in the environment. And we can also then monitor those password lists, look for any compromised systems that are out there, and by monitoring the Azure Active Directory, we can then identify users that have potentially compromised password, and we're only having to monitor our directories and to ensure that those passwords are not something that are being used out in the wild. When we're using Active Directory, there's usually three main methods of authentication, especially based around the password. There's the password synchronization model, the pass-through authentication, and the federated authentication. These are for a synced environment with an on-premise Active Directory environment. In a password synchronization environment, it's not actually the password that's synchronized, it's actually a hash. And that's why it's called password hash synchronization. And so in that scenario, there's a hash that when you set a password in Active Directory, it's kept on-premise, and then that hash is replicated into Azure AD. Any password changes that need to be made are actually made on-premise, and then they're then replicated up into Azure AD. Even if you enable password resets in Azure AD for those on-premise environments, what actually happens is that they're prompted through Azure AD to do the password change, and then when that password is actually generated by the user, that hash is sent to on-premise for validation, so that you can have any additional rules and any additional validation that you do for passwords on-premise, they can do down there, and then it's put into the on-premise Active Directory and then replicated back up into Azure AD. The other option is that if you don't want to have the password stored in Azure at all, you can do what's called a pass-through authentication. What a pass-through authentication is that in Azure AD, if you go to authenticate to it, it will accept that password from the user and then it will pass it to an agent on-premise in your Active Directory environment that then talks to your domain controller, validates that user on the fly, and then sends a response back to Azure AD whether or not the user is authenticated. By utilizing this tool, this ensures that none of the hashes are stored in Azure AD. So if you have a regulatory concern or some sort of additional concern that you don't want to have those hashes stored in Azure AD, you can continue to use your on-premise environment for those authentications. The downside, obviously, is that if that pass-through authentication agent is not available, we'll not be able to access or will not be able to authenticate any users to access any resources that are managed by Azure Active Directory. However, you can have multiple different pass-through agents. They can be in multiple different locations, and you can have multiple different redundancies. All they need to be is a single agent running on a secured system that can then talk to a domain controller. It's usually in most scenarios you have at least 3 of those agents. Many scenarios you may find that you have many additional ones to deal with the different dispersal that you have in your domain environment, but that's a potential option. The final option is what's called federation. Now, if you're going to be doing federation with Microsoft tools, there's Active Directory federated services, or you could potentially federate with third-party services as well. But the ADFS solutions allow you to do that federation on-premise. Most environments, if you already have ADFS in place, we may utilize that for AD. However, there aren't too many scenarios these days where you would generate an ADFS environment just to do ADFS with Azure. Usually most of those scenarios, they find pass-through authentication may be more productive for them. But if you find that you need to do federation, or that's something that you want to look into, you can integrate into Active Directory Federation services to federate your authentication. In those types of scenarios, what happens is the user puts in their username, Azure identifies that that domain is a federated domain, and then sends them over to the federation provider. That federation provider then authenticates them through whatever mechanisms that you configure for it, and then it sends back the token response to Azure AD to say that this user has been authenticated. In addition, some tools that are available in Azure are what are called identity protection risk events. These are where Azure can identify potential suspicious actions with the user, maybe a compromised or leaked password login, something where a user is using unusual login activity. For instance, if they've logging in from physical locations that are not practical for them to travel to. If you have a user logging into New York and then also logging into Tokyo and then logging into, say, Sao Paulo all within an hour, that is not physically possible. So therefore, it's probably a compromised login. And this is something that Azure can do to help identify those protection events and those risk events for logins. Also, if there's something where they may be logging in from an unfamiliar location, if the user always logs in from a single location or a single region, and they're suddenly logging in from a totally new region and they haven't been doing that, that will also be elevated as potential risk login as well. There's also the list of known or compromised potential environments that Azure tracks, and if there's any logins from those environments, those will be elevated as risky logins as well. There's a couple of different ways you can deal with these risky logins. You can set up the conditional access to where if there's a potential high risk threat, you may just deny that outright, and that user then has to reach out and identify, hey, I am who I say I am. We've been able to validate who that person is. Maybe you need to go off and address whatever that risky scenario is, but that gives you the ability to address it without somebody compromising your environment. In addition, you could also challenge that login with a multi-factor authentication challenge. For instance, if a user is logging from an unusual location, that may come up as a medium threat, and so you can configure that if there's a medium threat from an unknown location, challenge that MFA. So that user maybe didn't normally get challenged for MFA when they're logging in from the same location all the time, but when they've logged in from a new location, they get that challenge, and then they go through multi-factor authentication for the additional validation that they are who they say they are. There's a few different scenarios that you can do around this. The idea behind these is that we are doing these assessments in real time as the user is connecting to the environment. And this is something that is done when they go to authenticate to Azure AD, regardless of whether it's for an existing application or a new application. If they're going through Azure AD, we're looking at that login process to see where it's coming from and making that assessment. But the major advantage of this isn't something that you're having to then redeploy to multiple different applications in your environment, trying to make sure that each one of your applications all support this. By enabling this in Azure AD, all the applications that utilize Azure AD all have this functionality. And again, this happens when the user goes to authenticate to Azure AD and any time they're accessing a new application. As I mentioned before, this can be utilized for conditional access. And what conditional access is that we're utilizing signals of their login process to determine how we're going to allow them access to it. Those signals obviously are going to be the user, the location they're coming from, also whatever device they're connecting to or connecting from, whether it be a device that is a trusted device that is managed by your environment or a trusted device that they've just registered with your environment. Then also the application, what they're trying to access, whether it be an Azure portal, Microsoft 365, or maybe a custom application. Each one of those can be a different signal value so that you can determine how you want to elevate and deal with your particular environment. And then also the real-time risk assessment, which we just talked about. Based on those four signals, we can then determine how we want to allow that access. We can either allow the access to continue if it's a low environment, something that's been validated, or you can challenge it with multi-factor authentication. Or if it's something that's a very high risk or something that is something out of the ordinary that you don't want to trust, you can just outright block it immediately. Again, this is something that's done on the fly automatically for the environment to ensure that this is happening without any human intervention and is done immediately upon the detection of the user login. Another feature available in Azure is what's called access reviews. And this is a scenario that we run into a lot of times in IT where we have a particular system or a particular user that needs to have access to an application for a particular project, and it's only going to be temporary. This could be a guest user or it could be a user within your environment on an ongoing basis. It could even be something that is an administrator who's accessing an environment to do controls. The idea behind it is that it sets up an automated regular response that sends off to the management team or the administration team of a particular resource to say, should this user continue to have access? You can either set up like a one-time access review that says, I know this project's supposed to be going for 2 months. And so at the end of the 2 months, should they continue to have this access? And it has to be authorized from the management saying yes or no. And you can have an automatic response where if somebody doesn't respond to it, then you automatically remove it. They could also request additional time frame saying, yes, they need to have access for another couple of weeks. And you need to have this be an automated process. You can also have it go through an approval process. The nice thing about this is you can also do regular quarterly reviews or monthly reviews. So for those environments where you have an elevated access, you have an IT management team who are controlling your privileged access to your environment, you may want to ensure that they are regularly checked and that you don't have somebody who has moved on to another position. They may still be in the company, but they no longer need to have that elevated access. What you can do is have a quarterly review to validate that the administrator list is consistent with what you're expecting. And it doesn't necessarily have to be for central IT management. It could be for individual application, or it could be for just accessing an application for licensing purposes. So you can have these regular reviews that are automated by the system in Azure that send off that request. And you can have it either default to, if nobody responds, we remove their access. If they don't respond, then we go ahead and maintain it, and we ask them again in a future review, or whichever way you would like to handle it. What this assures is something where you have quarterly access or quarterly audits, especially, or even bi-yearly audits for access to environments. You can make sure that, yes, this has been validated on a regular basis and that you can make sure that they have access. But the reason why we're doing those audits in the first place is to make sure that that access wasn't there as well. That audit was just supposed to be doing a check in the first place. This is a tool to allow you to ensure that the access is exactly what you expect. It allows you to do regular access reviews to your resources to ensure that the right teams have access as needed. Also, each one of these reviews and the responses are also logged in the environment, so you can also come back and review those. So you can look to see who accessed it, who was authorizing it, what the list was, so you can also come back and review those for review time. It's a really great tool for any of those types of environments. It's highly useful for anybody who wants to keep track of who has access in any dynamic environment where you want to remove people on a regular basis and you want to make sure that there's only temporary access to the environment. It provides a quick, easy tool for you to be able to manage and maintain those types of environments. In addition to that, one of the other privilege roles that we have is what's called Privilege Identity Management, or PIM. The idea behind PIM is that there are usually several users that you want to have administrative access to an environment, but you don't want them to have administrative access all the time. It may be something that you just want them to be able to occasionally go in and make a change, but their day-to-day logins, you don't want them to have that access just because they happen to log into their machine. An example of this is that if you want to have somebody who has the ability to shut down and restart your virtual machines in Azure in a production environment, you may not want them to always have that ability, because if their system were compromised, they could potentially be a vector for somebody to come in and shut down your production environment. Obviously, that would be problematic. However, there may be scenarios where you have a problematic virtual machine that just becomes unresponsive because the application's chewed up too much memory and it's become unresponsive, and so your support team has to be able to go in there and shut it down. So you have these conflicting interests where you don't want somebody to be able to shut down your production environment just on a whim. You don't want their account to be able to be compromised. You want to have some sort of process that can document it, and they can request that access on the fly so that you're not having to be in a down state long term. Maybe you haven't set up your alerts and responses accordingly, and so you need to have some sort of manual response. What the PIM allows that person to do that you've delegated to have that privileged access is they can go into PIM and say, hey, I need to have access. You can force them to include a ticket number. For instance, if you're using ITIL's tools or ITSM ticketing tool, you can also require them to put in justification as to what the reason is, and you can have them then request that access. You can either set them up to automatically be approved, or you can have it have to be manually reviewed if you want to have a manual review process. But then once it's been approved, they then have access for a limited time frame, which again you can configure for an hour, 2 hours, 8 hours, and they have that privileged access for that time period. Once that time period expires, they go back down to their normal access. So common scenarios that you maybe give them reader access to your tools or reader access to your environment so they can monitor the environment, see what the status is, and see what's going on in the space. But then you want them to be able to do a virtual machine contributor periodically to be able to make those changes. And that's something that you might see in some environments. You can also use it for very high privilege roles for something like a global admin access in Azure AD. If you want to give them the ability to be global administrator, but you want it to be something that is only done on the fly and only done under a review process, you can set that up to give them global admin access for temporary privilege, maybe for setting up an application, something that required global admin privileges. They could do that as well as the part of the PIM process. In addition, you have the Azure Hierarchy. The Azure Hierarchy is where you can organize your resources within the Azure environment so that we can do a organizational structure of your resources and settings. Some people don't realize that once you move into Azure, the subscription that you start off with is potentially just one subscription of potential thousands. By doing this, what we can do is we can put your different subscriptions into management groups, and those management groups can be tiered together in a tree structure. And then obviously we have our resource groups where we put our resources into. By putting the hierarchy in place, what that allows us to do is we can set permissions and policies at different levels of this tree that will then inherit all the way down. So we can set up standards for policies or standards for permissions at a management group level, and then any subscriptions that are created underneath that management group level immediately have those policies and settings as well. This is a very common tool that we have to help ensure that we have consistency, controls, and management in the Azure environment. Then we can also have our Azure policies. If you're not familiar with the policies in Azure, the idea behind a policy is that we set up guidelines and roles and restrictions for the Azure spaces so we can ensure that we have consistent standards across our environments and our resources. These can be any property of a resource within Azure. We can also set it up to where it's either just audited or required. Policies will not prevent an existing system that is running out there from running. Instead, they will just flag an audit saying that this is something that doesn't comply and give you the documentation to go off and make those changes to that user or to that resource in Azure. You can also set up the policies to have one-touch or modification so that if they want to remediate a particular issue, there's a button available for them to automatically go through and make those changes to it. That's very common in a lot of agent policy base. We can also set up groups of policies and initiative to create a consistent compliancy standards. For instance, there are built-in initiatives for things like HIPAA, NIST, PCI type of compliance in Azure. By doing an initiative that groups all the policies together to reach that particular environment or that potential security standard, and just apply that single initiative, will then allow all those tools to immediately be deployed as the policies and come up in a single audit review into report that you can see what's going on in your environment. You can create your own custom policies for your environments. And you can also configure policies to where if something that is new or being changed does not comply with your compliancy, that change does not go forward, and the systems continue to run as were. So there's a few different options around those. So that way you can ensure that you have good, consistent, secure standards throughout your environment. Everything from just the names of the resources to the configurations of the resources. Lots of different options around those policies. Then obviously we have our RBAC permissions. If you haven't worked with Azure before, the RBACs are how we do our permissions. The idea behind RBAC is that by default, nobody has access to anything in Azure. You have to be granted access to Azure. And the expectation is that zero trust model, and only the rights that are needed to achieve your access or achieve your roles needs will be defined in your role definition. So we'll have only those permissions that you need to achieve a particular role in that role definition, and then we assign that role definition to a user in a particular scope, being like a resource or resource group, and then those permissions are inherited down through the rest of the scope. As we talked about earlier, we had the hierarchies. You could apply those permissions to a resource group and then have it go down to the individual resources as well. In addition, we also have what are called service endpoints in our networking spaces. What service endpoints allow you to do is have a PaaS resource in Azure, be able to be accessed by your infrastructure as a service types of tools directly without having to go through a public IP interface. Traditionally speaking, if you're going to be accessing something like a storage account or SQL PaaS system, you would be going out through a public interface and then accessing those tools. By having a service endpoint that allows us to access this directly, this allows us to have more concise permissions and firewalls on those storage accounts, those tools. So we can say that only certain areas in your private networking space have access to it without having to assign public IP addresses to those resources. It also allows simplified management and more direct networking communications. But this is just a simple way to be able to get private IPs to limit your firewall access to your public resources in Azure. In addition, we can also do what's called a private endpoint. Private endpoint is where we can have a IP address in your infrastructure as a service environment assigned to a Azure resource. This can be something that is like a SQL PaaS database, a web app, storage account. This allows you to then set up NSG rules to limit access to that resource, and also ensures that everything is routing directly to that private IP address of that resource that you have registered for a private endpoint. This can also be used to access resources from on-premise across a VPN or private network connection into your Azure space by simply addressing the private IP address of the PaaS service that's been associated by your private endpoint. Another edge device when we're getting into the Azure space is an application gateway. The application gateway is designed primarily for using HTTP traffic and securing it on the edge. You can also integrate it with a web application firewall. This type of tool allows you to ensure that all the web requests that are coming into your application pass a certain standard. You can then also route it based on what those web requests are. You can also ensure that all the TLS communication is hitting the front end, and that only those communications what gets to the back end without having to have any HTTP exposed to the public internet. You can have the routing and redirection done directly on the application gateways. And directly, you can also do rule-based routing and rewriting of the headers for those services, and then also the back end can be any address that's out there. You can either have it do privately to your virtual machines or web apps within your environment, but you can also have a reference an external URL if you need to front end your on-premise environments. So for example, you can have the public DNS reference the application gateway. The application gateway can then talk to your on-premise environment. So if you have an application that maybe has not been fully secured and you want to make sure it is secured, you could redirect that traffic through the application gateway. It can then send that communication to your on-premise. You can configure your on-premise then to only accept traffic from the application gateway. So there's those types of scenarios as well. This is a device that you can use to do that edge communication for your web traffic. And then on top of that, you also have the Azure Front Door, where we basically take that same concept, but we expand it out to a global deployment scenario. Whereas an application is a single resource in a single region, Azure Front Door is a PaaS service that encompasses the entire globe. So that you can have multi-site hosting, you can have the URL rewrites, you can do your application security all within a single edge service that is available across the entire planet. Then those were obviously really good for web traffic. The Azure Firewall service is also a service that's available to secure any traffic, whether it be a web request coming in or a SQL request or inter-site communications within your virtual network. The Azure Firewall is a managed service that has a base level setup where when you deploy it is immediately highly available, but is also what's called infinitely scalable. Because of the design of the Azure firewalls, that it will process any data that you send across that Azure firewall as long as the wire speed supports it. The Azure firewall will continue to process any data that comes across the traffic, any traffic that is directed across the Azure firewall. Unlike a lot of the virtual network appliances that are provided in third-party tools, which work really good at doing the traffic, you have to scale those based on what your max traffic is supposed to be. The Azure Firewall service will continue to grow and expand as you send data, regardless of what type of data you're sending across. It will scale infinitely, and it will scale back down whenever that bandwidth is not needed. Because of this, it works really well in a hub and spoke type of architecture, where you can have a shared firewall in a particular region that then multiple different spokes send data across the Azure firewall. You can use the Azure firewall to control traffic outbound as well as inbound. You can also use URL filtering as well as categorizing of websites for outbound traffic. This becomes a really great scenario for anything that you want to secure on premise, as well as anything like a VDI type of deployment where you have users coming in and accessing the Azure virtual desktop and then browse to the outside world. You can use the Azure firewall to ensure that that web traffic is secured and limited as well. When you need to access and manage the Azure environment, remote desktop is obviously one of the normal processes, as well as SSH for Linux-based systems. However, those ports are something that you don't want to have exposed on the internet and the public facing. There is a tool called just-in-time access where you can expose those ports temporarily, but there's also what's called the Azure Bastion remote access. What the Azure Bastion is that is a service that is provided for in-browser connections to any virtual machine in your virtual network. You set the Azure Bastion, you log into Azure Portal, you go through the website, and then you can access either RDP or SSH via the browser. The nice thing about this is that the Azure Bastion, you're talking to across TLS, but the port that is used for management, whether it be RDP or SSH, is still kept within your virtual network. This traffic never actually leaves your virtual network, it's just exposed as a GUI interface on the portal. So this ensures that there is no SSH commands coming across from the internet or any RDP clicks or text entry across those, and you're not having to expose any of the ports. Another tool available in the Azure environment is update management. What this allows you to do is have a centralized update management, regardless of whether you're running Windows or Linux. Without having to go through Windows Update, you can then secure and set up your update of your resources in Azure, so that you can ensure that they're always kept up to date without having to have a centralized what's a server. And you can also get reports to identify any machines that are not being updated on a regular basis. If you're going to be deploying a Kubernetes cluster type of environment in Azure, the Azure Kubernetes Service provides you lots of different security around it as well. It can integrate directly with Azure AD again, so you don't have to maintain a different set of users to access your Kubernetes environment. And the AKS environment is aware of Azure AD and can integrate directly with those groups, so that you can then delegate access within AKS itself to a particular user or group grant them access to within your AKS management roles. You can also utilize the traditional networking environments within Azure for things like your NSGs, firewalls, and other types of networking security. You can also utilize that with your AKS environment, so you're not having to go through and reinvent your firewall rules and firewall settings. You can continue to use your existing environments and existing settings and still be able to utilize them with your AKS. You can also use your managed identities for having access permissions from your AKS resources directly to authenticate an application in Azure or access their management tools within Azure. You can set them up with their managed identities, much like you would for a server's account on on-premise environment. Then you can also utilize your key vaults for access to your resources, store your passwords and those security needs in the key vault as well, so you're not having to maintain a separate data store for those privileged information details. If you haven't worked with a key vault before, the key vault is something that is used to store secrets such as passwords, certificates, as well as keys for encryption. It also provides you the ability to automatically rotate those certificates. If you register with third-party providers for your certificate management, you can have those certificates regularly updated. You can also utilize the APIs with the key vault to maintain those requests and send off alerts when those are going to expire. You can also utilize the protected keys for your hardware management. If you want to do disk encryption or higher level encryption, you can also utilize the hardware security modules for storing your keys that require those features. Another frequent tool that's available for you is what's called managed identities. Managed identities actually allow your resources to authenticate and register directly with Azure AD, and then you can grant them permissions based on those management IDs. One common scenario is a virtual machine where you have some sort of management code to control or manage your Azure environment. In this type of scenario, what you can do is actually create a managed identity, assign it to a virtual machine. That virtual machine now has the identity as long as that machine exists. If you worked on a on-premise environment in Active Directory in the past, service accounts for servers would be something that would be common out there. And those types of scenarios, you would want to grant that machine access maybe to an external database or another environment. Same type of thing here. The managed identity is another user and account, basically an Azure AD, that you can then assign permissions. So you could grant a virtual machine the ability to maybe scale up other virtual machines. You would have ones that would monitor your environment, and if you had additional resources that need to spin up, you could have an agent that's running on your virtual machine that then accesses the environment to deploy additional virtual machines or scale up the virtual machines. The nice thing about using that managed identity is that service can register with that with your operating system and say, hey, you need to access it. It has no direct access to the identity. It has no way to store those credentials. And so that way you're sure that those credentials are never going to be used anywhere except on that virtual machine itself. And it's all done on a token-based system, so that you can ensure that those applications are only accessing that information on the fly as needed. Another common tool is with Azure SQL Server. We can set it up to use Azure AD authentication. And these types of scenarios, rather than, again, having to maintain a user and permission database within the SQL Server itself, instead what we can do is utilize our Azure AD for single sign-on. We can also do group authentication. And then we can also use those managed identities that we talked about with a virtual machine. Same type of thing is that we can have a managed identity on that virtual machine for that application to access your SQL database. Again, your application doesn't have to be aware of the identity itself. It doesn't have direct access to the identity. Instead, what you can say is that this virtual machine has access to authenticate to this SQL server. You can then authenticate as that account into the environment. You can then also ensure that your users that are going to manage and maintain the Azure AD Active Database are going to continue to use the same identity provided that they use to access other environments for the Azure AD space. And so there we can still use that multi-factor authentication. We can utilize the risk assessment for the logins, and we can also do conditional access to ensure that they're accessing those tools on the fly. We can make sure that we're identifying and monitoring the logins all from that central authority. We can also do database auditing to ensure that we are maintaining our database activity, ensuring what's going on with those databases, and ensuring that we are excuse me, aware of the access that's going on in the environment and accessing those tools. We can also do our data discovery and classification. These are tools with the Azure SQL environment where we can look at the columns, look at the data within those columns, and make recommendations based on those environments. It can identify potentially confidential sources and confidential details within each one of those tables. This is an automatic classification service that you can enable on your SQL databases to help you identify which columns need to be protected more explicitly. Some of those protections that we can do dynamic data masking. For instance, if there's a particular field that you want to make sure is not exposed except for those people that need to have access to it, you can set up dynamic data masking so that even if an account that has access to that table were to dump out the data, all they would get is masked information dynamically. By having dynamic data masking, we can ensure that the data is not frequently or is not accessed inappropriately, and that we don't have a compromised account that is then able to access information just by the ability to select information out of a table. We can ensure that their sensitive data is still masked, even though they may have dumped out the contents of a table. And then even further, we can also do data encryption, where we can have transparent data encrypted on the fly, so we can ensure that individual columns or details are encrypted as well on our databases. That's just a quick summary of a lot of tools that were in Azure. So then we can get into a lot of the more threat protection. Threat protection is where we define more as a dynamic response and being able to identify the tools that are happening in access to that environment that may be monitoring on a dynamic nature, and that we're trying to keep track of the information and access without having to have initially a whole lot of pre-configured settings. A lot of the tools that we talked about earlier are ways that we can set up and configure our security. However, there's always potential threats that may come into the environment that are unexpected. This is where we get into the Microsoft Defender tools. With the Defender tools, we have lots of different options for the different resources that we have in Azure to protect and secure our data and monitor that access to that data. With the Microsoft Defender platform, we have a single pane where we can come in and see the different environments, what's in the what the status of the different systems are. We categorize them out by the different types and let you know what the different areas are. These are tools that are available, again, not just for endpoints anymore, but also for most common Azure resources. However, for the endpoints, for things like individual virtual machines or individual servers, or even endpoint devices such as virtual machine, or excuse me, such as laptops, mobile devices, and other things, we do have Microsoft Defender to help prevent, or help protect and control those resources. By having credential guard on those environments, we can isolate the security storage of the identities for accessing the tools. We can also have the application control to make sure that we don't have any spyware and other compromising environments. Again, these can all be then reported back to a central resource in Azure. We can utilize that data set to help identify any potential breaches in their environment. There's also the Microsoft Defender for multiple Azure PaaS services. Most major PaaS services in Azure you'll see have some form of Microsoft Defender, and this list continues to grow on a regular basis. They continue to expand this platform, and the idea here is that we can utilize the Microsoft Defender tools and platforms to help secure and identify potential vulnerabilities and issues in our environments. Once we have those potential environments and the management and monitoring of those, we also want to find out ways that we can manage and respond with those threats. The main environment that we would use with those, the Azure Security Center, which is a function within the Microsoft Defender platform. And this is a centralized hub where we can have our alerts come into place. We can then respond to and detect potential problems in the environment. Now, the basis of the Azure Security Center, which is actually now part of Microsoft Defender, is the metrics and logs that come in from different resources. You can have those come in from not only the Azure environment, but the different resources that you have connected to your space. You can have multiple different connected sources that come into your environment, whether it be Windows, Linux systems that are in Azure, or from your on-premise environment, or from other cloud providers or other data sets. We have multiple different data points come into the Azure environment. We can then utilize those to set up our alerts and set up the security notifications for our environment. We can then set up the alerts to send off notifications to the appropriate teams. We can also have those alerts be automatic responses, whether it be something like an automation tool or a logic app. Excuse me. We can have the conditions be multiple different values. We can either be an alert log that came in for a particular problem, maybe a login issue that you saw from a user. You can have it then elevate an alert and send off to your security team. You could also set up alerts based around a machine that was no longer available. So if you have a heartbeat that has been missed for several minutes, you can set up alerts. You do that. The idea behind the alerting system in Azure is that we can have a single alert system regardless of what type of platform we're running on and regardless of what type of environment we have. We can all use the same logs and same environment to do the same alerts. We can also utilize the same responses regardless of what type of platform we're coming from. Again, we can use the same tools for it. And the monitoring of the users the alerting to the response team can either be through email, phone calls, text messages, mobile app responses if you have the Azure app on your mobile device. We can also, again, send it to a ticketing tool or a web endpoint or a logic app or other automation tool in Azure. We can also utilize the Azure security policies to set up standard security standards through their environments. So again, we have several different predefined regulatory standards for that, and then anything that violates those policies will be elevated in the security environment and as well in Azure. So you can look at those responses and see if there's anybody that was violating a particular policy that will show up as well in the security center, so that way you can ensure that your environment maintains the standards on an ongoing basis. You can also have the Azure Security Center will make recommendations to your tools and to your environment. And you can filter out, in this particular case, they're showing a filter here of virtual machines. You can filter out for several different types of the resources in your environment. And you'll notice it's giving you a score of the environment. The idea here is that these scores are helping you identify which are those potential systems that have the most impact to your environment. The max score is obviously the highest level that you can get. And so those values that have a higher score are the ones that usually have a more impact or have a higher impact on the security of your platform. Those with the lower scores tend to have a little bit lesser impact or lesser direct inference on your security stance. However, this tells you what the current score is and lets you identify ones that you can then increase faster and get to a higher security level. Another response tool that we have available to us is the Azure Sentinel. With the Azure Sentinel, it can utilize those same logs that we've been sitting in the Azure Security Center and the Azure Security Platform to identify what's been happening in your environment. We can also connect with additional resources outside of Azure. So if you want to bring in logs from something like a Splunk environment, or if you have a external firewall, syslog, something like that you want to bring in, we can also bring in additional connections, and we can also bring in connections from additional cloud environments. So if you there are multiple different connectors that are available, so we can bring in those environments. And the idea behind Sentinel is that we can then respond to additional threats and hunt down through those threats through the logs and look for correlating events to help identify any potential threats and rapidly respond to any of those environments, those potential scenarios. With the Azure Sentinel, we have multiple different data connections, as I mentioned. You can put in just those connections as part of your configuration for your Sentinel, and you can grab through, on this particular one, there was 98 connectors. That number has continued to increase. So if there is something that you have as additional resource, even outside of Azure, we can pull in those logs and pull those utils into Sentinel and allow Sentinel to be able to help identify your potential threats coming into your environment. Those threats, as they've evaluated through those connections, will generate into incidences. Those incidents are then based on severity, based on the rules that they triggered. So you can help identify which ones are those more frequently ones. And then again, those tools provide some additional hunting and tracking of that information as it goes through your environment. We've gone over a lot of the security tools in Azure, as well as the threat protection, and again, alerting and responding to potential threats. Hopefully this was a good understanding from the Azure platform and the security and threat responses available in Azure. Thank you very much for your time. I appreciate you coming out. If you have any questions, please feel free to reach out. Again, my name is Kit Skinner with Ops Agility and Skill Me Up.